All right, so we are working on this last question, the question with the truck going at a constant velocity to the right, and it tells us the weight of the truck, or excuse me, the mass of the truck, the mass of the crate. It's initially traveling at this 25 meters per second, and then it applies the brakes. And as it slows down, the truck travels 55 meters. All right, so let's go ahead and underline things. We know this is our velocity. This is our change in x. And then what happens? So we apply the brakes. So we're slowing down, and in the next 3 seconds. All right. So this first question wants the acceleration of the truck. This is just kinematics. All right. So let's bring this down, part A down, and we are looking for what is this acceleration? Well, what do we know? We know that our initial velocity is 25 meters per second, so V naught is 25 meters per second. We know that our change in x is 55 meters, and we know that our time, t, is going to be 3 seconds. So using this information, we can find our acceleration, and we can do that by using this wonderful beautiful equation of change in x equals v naught t plus 1/2 at squared. And we are looking for this acceleration, and yes, we do have an initial velocity, so we have to keep that. So let's first subtract that out. So we get change in x minus v naught t equals 1/2 at squared. Multiply both sides by 2 to get rid of that 1/2. And then divide both sides by t squared. Then you end up with acceleration equals 2 times change in x minus v naught t, all divided by t squared. Now I just need to plug in. So acceleration equals 2 times 55 minus 25 times 3 divided by our t squared, so our 3 squared. And we should end up with an acceleration equaling negative 4.4 meters per second squared. And the reason why it's negative is because we made our initial velocity positive, and our initial velocity is positive, it's going to the right. That means our acceleration is going to the left. It's going against that velocity. All right, so then part B wants us to draw and label the forces acting on the crate during the braking. So we see a very important sentence at the end. The crate does not slide along the back of the truck. What is stopping that motion? It's going to be friction. Friction makes it so that this box does not slide forward. Because if you think about it when you brake, your body goes forward. And so this this box just wants to go forward. And so the force acting against it is going to be this friction going backwards. Also, it is on a surface, therefore we have a normal force acting parallel to that surface. And always and forever, unless we are in outer space, we have this mg, this gravity. So that is part B. And we do not have any other forces acting on this. We do have the acceleration going forward, but it is due to this truck. And so now let's look at part C, I. It wants to calculate the minimum coefficient of friction. So that's going to be our mu between the crate and the truck that prevents the crate from sliding. So it is preventing the crate from sliding. All right, and so pretty much right now what we're about to do is we are going to say the sum of the forces in the x direction. There is some acceleration trying to act on this box. And so we are going to have to say mass times acceleration is going to just equal that frictional force. All right. And so friction, we know, is going to be this mu times normal. And we see that this box is not accelerating upward or downward. And so we see that this normal is in balance with this mg. And so we know that some of the forces are 0 in the y direction. And so this normal must equal our mg. And so we can just go ahead and say the friction is equal to mu times mg. And so then we get ma equals mu mg. We can cross out our m's, divide by our g, and so we get mu equals the acceleration divided by gravity. And so that's going to be mu equals the acceleration, which we found to be 4.4 meters per second squared, divided by 10 meters per second squared. We end up with 0.44 as our coefficient of friction. All right, then part 2 asks, is this friction static or kinetic? Static means still. Kinetic is like as in kinetic energy is in motion. And so this box or crate does not slide, therefore it is still, it is static.